The creation of the Earth is a topic that has been studied and debated for centuries by scientists and theologians alike. The most widely accepted theory for the formation of the Earth is known as the Big Bang Theory, which states that the universe began as a singularity, a point of infinite density and temperature. This singularity then expanded and cooled, eventually forming the stars and galaxies we see today. Within this expanding universe, gravity pulled together clouds of gas and dust, known as protoplanetary disks, which eventually formed into the planets we know today, including the Earth. The process of the Earth's formation began about 4.6 billion years ago, with the formation of a cloud of dust and gas known as the solar nebula. This cloud was made up of hydrogen and helium, along with smaller amounts of other elements such as carbon, oxygen, and silicon. As the cloud began to collapse under its own gravity, it began to spin, flattening into a disk shape. As the disk continued to collapse, it began to heat up, and small particles of dust and ice began to stick together to form larger and larger clumps. These clumps eventually grew into planetesimals, which were the building blocks of the planets. As the planetesimals continued to collide and merge, they formed larger and larger bodies, known as protoplanets. These protoplanets continued to collide and merge, eventually forming the inner planets, including the Earth. The early Earth was a hot, molten ball of rock and metal, with a thick atmosphere of gases such as hydrogen and helium. As the Earth cooled and solidified, heavy elements such as iron and nickel sank to the center, forming the core. Lighter elements such as silicon and oxygen formed the mantle and crust. Over time, the Earth's surface cooled and solidified, forming the first oceans and atmosphere. Volcanic activity also played a crucial role in the formation of the Earth's surface, as it spewed out gases and minerals that eventually formed the atmosphere and oceans. As the Earth continued to cool, water began to condense and rain down, forming the oceans. The oceans and atmosphere also began to interact, with water evaporating and raining back down, leading to the formation of weather patterns and the formation of the first life forms. The Earth's atmosphere also changed over time, with the first primitive atmosphere being made mostly of gases like methane, ammonia, and water vapor. Over time, these gases were replaced by the more familiar mixture of nitrogen, oxygen, and carbon dioxide. The Earth's magnetic field also formed over time, as the core began to solidify and the rotation of the Earth caused the liquid outer core to begin to spin. This spinning created a dynamo effect, which generated the magnetic field that still protects the Earth from harmful solar radiation today. In conclusion, the Earth's formation was a complex and dynamic process that occurred over billions of years. The collision and merging of planetesimals, the cooling and solidification of the Earth's surface, and the formation of the oceans and atmosphere all played crucial roles in the creation of the planet we call home. Today, scientists continue to study the Earth's formation and evolution in order to better understand our planet and its place in the universe.